So, hi everyone, welcome to the third workshop in the Yellow Bisthorn Hackathon series brought to you by Bisthorn. I'm Weber from Bisthorn team. I'll be the host for the today. Earlier, we had a multiple people like Mansi and Mehek to host this workshop. This is the third workshop. So, before we jump to the today's session, let's do a quick recap of what happened last time or last workshop. In the previous workshop, Andrew and Maxim showed us how to build a fast and efficient Web3 dApps using Yellow SDK. And we got into some really cool stuff in last workshop. And if you haven't joined the last workshop, we have the recorded video available on our communities and on our website. You can go watch that. If you don't able to find them, let us know in the community. We'll provide that. So last workshop, how Yellow State Channel help create real-time gasless experience. There were a live demo, hands-on ideas, and lot of practical learning around using natural light protocol. And today we are diving even deeper. We have got Nikita and Anton with us. They will walk us through the Yellow protocol and the how smart contract work with it. Okay. So more on our guest shortly. So before we move ahead, let's me quickly introduce the Bisthon. For those who are coming for the first time, I'm sure that most of the people know the Bisthon, but yeah, it's the formality of telling people, reminding people what Bisthon is, what the vision of the Bisthon. So Bisthon is a developer-focused hackathon platform powered by TD5, dedicated to fostering the innovation through hackathon and community-driven initiatives. Our mission goes beyond just organizing hackathon. We meant that participants help them develop their product, build community, and even acquire their very first client or make the very first dollar for their company. Our goal is to help developer like you to turn your idea into business. And we have worked with blockchains like Solana, XRP, Bahamut, Koti, ICP, and now we are building with Yellow and helping with Yellows to expand, and we are helping developers to integrate Yellow to make a gasless Web2 UX type of a projects. Now let's bring the energy into the room. GM again or the country name. And without taking more of your time, it's my pleasure to invite today's speaker Nikita and Anton to take the stage and introduce about themselves and start the presentation. Over to you, Nikita and Anton. Thank you, guys.
Hello, everyone. So let's start the presentation. Firstly, can you see the screen?
Yes.
All right. So, hey, everyone, and welcome. My name is Nikita Sazonov. I am the lead blockchain developer at Yellow. With me is Anton Filonenko, our senior software engineer. Today, we are here to continue exploring Yellow Network, and our journey consists of two parts. First, I'm going to explain the on-chain logic behind Neutralite and the main implementation contract that is responsible for user funds and dispute resolution. And then I'll hand it over to Anton to present a CLI application that will give you the opportunity to experiment with the smart contracts and instant payments in your terminal. So let's start with the first topic, how Yellow Network is backed up on-chain. Let's revise where does the on-chain part stand in the bigger picture of Yellow SDK. So here is an existing Web3 application. It can be React, Node, Golang, whatever. On the other side is a Yellow node. It routes messages and keeps the off-chain channel state. It can be thought of as lightweight ledger and message broker that abstracts the chain for us. The decentralized application connects to the Yellow node through the Yellow SDK. Under it, there is a Neutralite RPC and a WebSocket. And finally, when a user wants to enter the network, needs finality or a dispute occurs, we go on chain. The contract handles custody, mutual close, and the challenge response process. Now, let me show in more details what the smart contract part consists of. These interfaces define the expected behavior, our on-chain components. Firstly, iChannel covers the main lifecycle functions like create, join, and close.
I think
iChannel
somebody's
reader
audio is missing in the meeting.
iChannel reader exposes read-only channel data. iDeposit abstracts token deposit and withdrawal. iAdjudicator defines how to validate state transitions for application-specific logic. Next, let's see the main types that Neutralites operate on. Channel is the on-chain configuration that uniquely identifies a channel instance. It defines who participates, which adjudicator will validate state, how long dispute lasts, and ensures each channel is uniquely distinguishable. It is the fixed reference point for all off-chain states. A state is the evolving snapshot that participants cosign off-chain. It represents the current outcome of the channel, including app-specific data, allocations, and participant signatures. States are exchanged off-chain for efficiency and only submitted on-chain for closure or in case of disputes. State intent indicates the purpose or a phase of a state within the channel lifecycle, whether it is for normal operation, initialization, resizing, or finalization, guiding how the on-chain logic and adjudicator should process it. App describes the virtual application layer for the off-chain governance and authorization. It defines how participants collaborate to produce valid states, including the sign-in set, quorum, and configuration that the adjudicator uses to validate state transitions. There are also several type definitions that are used throughout the protocol. Channel ID, which is a hashed channel structure with a chain ID, and the packed state, which is an RLP encoding of a channel ID and all state fields except for the signatures. Actually, the signatures field in state contains participant signatures over this packed state. Now let's proceed to what is an adjudication mechanism. Adjudication is a process of verifying whether the new suggested state is correct and whether a transition from a set of previous states to a new one is valid. In the context of adjudicator, the new state is called a candidate, and a set of previous states is a proof. Candidate is validated in terms of the application developed, either a simple payment app or a multiplayer game, and this is made possible by encoding app-specific data into a data field of the state. Additionally, participant signatures are validated. A transition from proof to candidate is validated not only in terms of application state, but also by verifying the fund's distribution stays correct. Application developers definitely would not want any financial surprises in their end. If a candidate state or proof candidate transition is deemed invalid, adjudicator returns false and any action that was performed on the state channel is reverted. Now, let's see what adjudicator implementations look like. An adjudicator contract must implement the adjudicate function, which takes a channel ID, a proof, and the candidate state, and returns whether the transition from proof to candidate is valid and a candidate state is correct in terms of the application logic. In Yellow, we have developed several adjudicators, and the most prominent are simple consensus adjudicator, which defines valid state as one containing signatures from all participants. In this case, proof is not required. And the remittance adjudicator, which includes a remittance structure in the data state field. The validation rules are the following. Each state must include a remittance. Each state allocation must correctly reflect the remittance. A candidate must be signed by the sender specified in the remittance. If other party has signed the candidate as well, then proof is not needed. Otherwise, approved must be a valid sequence of updates, starting with the one containing the signature of the other party. Now let's proceed to the concrete smart contract implementation, which defines the logic and state rules. The custody contract is the backbone of Neutralites on-chain side. It implements the key interfaces to manage deposits, track channel status, and enforce the protocol. Additionally, it locks funds when a channel is created, ensures correct allocations, and only releases them according to agreed rules. It also verifies participant signatures against state hashes, ensuring no unauthorized state can infiltrate the system. Moreover, it validates each state transition, executing the adjudicator contract specified in the channel a certain state pertains to. Now let's see how custody manages user funds. Custody smart contract implements two types of accounting. First is custody deposited, which is also called available. This is the implementation of iDeposit interface, meaning deposit and withdraw methods are the interaction point. One of the features is that a party is able to deposit funds to other accounts. It should be also highlighted that a user is able to withdraw funds at any point of time without any confirmation needed. Another accounting type is channel locked, which is also known as simply locked. Funds transfer to this account when a user opens a channel and are moved back to available when user closes a channel. Also, a resize channel operation can be used to either top up an existing channel with available balance or partially withdraw funds from the channel balance. It is impossible to withdraw funds that are locked. You must close the channel first. Thus, it can be summarized that a channel is custody, that a custody deposited balance can be directly transferred from and to the outside, while the channel locked one can only be updated to and from the custody deposited. Next, let's review the successful transitions of channel lifecycle. Firstly, there are the following positive statuses a channel can be in. Void is when channel is not yet created, at least on chain. Created is when channel is known to be on chain and some participants have joined it. Active is when all participants have joined the channel and some meaningful state transition might have already occurred. And close is when a channel has been unanimously agreed to be closed. Next, let's describe transition rules between these states. A channel transitions from void to created on create method when an initial state is supplied with the signature of initiator. A channel can also transition from void directly to active if an initial state is supplied with signatures from all participants of the channel. However, if that's not the case, then a channel might transition from create to active after all participants have called join with the respective channel ID and signature. Later, participants may invoke several repetitive operations. First, resize, which allows to change the amount of funds allocated to this channel, and also checkpoint, which acknowledges the contract about an updated state. And finally, when participants agree they want to close the channel, they submit a state with finalize intent signed unanimously. Now let's see what are the possible unhappy paths in a channel lifecycle. Unhappy paths include new channel lifecycle statuses, which are disputed is when a channel has undergone a challenge, and challenge elapsed is when a channel was automatically finalized with a challenge state, but the funds are still locked. And transition rules are the following. A channel can transition from created to close when a creator invokes a challenge with an initial state. A channel can transition from active to disputed when any of the participant challenges the channel with the valid state, which is newer than the latest known on chain. A channel can transition from disputed to active when any of the participants, including the one that initiated the challenge, checkpoints and a channel with a valid state, which is newer than the one supplied during the challenge. If a dispute was not resolved happily, then after a challenge duration time elapses, a channel automatically transitions to challenge elapsed state. And finally, a channel can transition from challenge elapsed to closed when any of the participant calls close, releasing all channel allocations to respective destinations. And now let's see what features and security properties custody provides. Currently, custody only supports channels between two participants. The most common use case is a channel between a user and the node, which in fact gives the access to the Yellow network. We think that this greatly simplifies the on-chain state channels part, allowing to focus more on the virtual application and the network itself. Additionally, custody supports several signature formats, such as raw CDSA, EIP 191, EIP 712, EIP 1271, and EIP 6492. It should be noted that security in Neutralite relies on strict signatures requirements. No state is accepted without the proper participant signatures. The challenge period ensures parties can dispute invalid or outdated states before funds are released. Flaggable app-specific adjudicator rules prevent unauthorized channel progress and fund movement. And importantly, the contracts have undergone a security audit by Omnitia, which adds an extra layer of confidence in the implementation. Now, let me hand it over to Anton with Cerebro CLI, a way for you to interact with the on-chain part I have just described.
Hello, everyone. My name is Anton Filonenko, and I am a senior software engineer at Yellow. Few words about myself. I work in this company for almost 4 years, mainly focusing on networking, observability, performance, automation, and security. I'm the one of the core developers behind our state channel infrastructure, and today I want to introduce you to Cerebro CLI. Please, the next slide. Thanks. When we started building Cerebro, it was planned as a simple bridge example CLI, just a basic demonstration on how to interact with our state channel infrastructure. However, as we dove deeper into development and started gathering feedback, Cerebro has transformed into a really powerful tool that abstracts away the complexities of cross-chain channel management and custody operations. So, a simple example turned it into a comprehensive solution that developers actually want to use. And you can use it as well, both as a tool and as an example. After the tutorial, we will show you where the code base is located. Now let me switch to the terminal so I can show how we can use Cerebro to bridge some funds from Polygon to Base. I have Cerebro command already installed, but if you want to install it, you would want to use the following command. You would need the link. When you will see the QR code in the end of this tutorial, you can go to the code base and read README and install it. First of all, I will export the following environment variable to use the fresh configuration. So we will go with you from scratch. Let's run Cerebro. As the only argument that we are passing here is the WebSocket link to our Clear node. Currently, we have the only one node in production. When you entered the interactive CLI, you can see the comprehensive suggestions and can freely examine all the commands that you have. Before we can start the main flow, we need to import 3 essential components. The first one is wallet. Let's name it Eris. I prepared the separate private key for the sake of this tutorial. Wallet is where your funds are located, where you will withdraw from our system. That is the destination, and wallet provides the first step in authentication flow into our system. Next, you will need a signer. Let's name it Erika. I have a private key prepared for it as well. Signer is mainly used for signing channel states that will be later submitted to the custody contract. It proves that we are the participant of this channel. Also, Signer provides the additional security to our authenticated connection to the Clear node. Next, we'll need to import chain RPCs for Base, also prepared, and for Polygon in order to query custody contract and submit transactions there. The first command you will almost always run is authenticate. While you Writing it, you can see that our interactive interface suggests you what wallet to choose and what signer to use as well. When authentication was successful, you are welcomed with your user tag that you can use later to receive some funds from other users. So let's examine what we have here. We can list our wallets, our signers, and chains. By chains, you see all the networks that are currently supported by our node and all assets that are currently supported by each of these nodes. Also, you can see here the number of RPCs that we added per each of the chain. Also, we have list channels command. For now, its output is pretty similar to the list chains because we don't have any open channel. Before we will open channel, let's deposit some funds on Polygon. We will use deposit custody Polygon command and specify, as I said, that we want to deposit. We will deposit, for example, 0.1. Under the hood, it makes the blockchain transaction to our custody contract on Polygon chain that moves your funds from your wallet to the custody ledger. Think of it as a staging area between your wallet and our network. Next, let's open a channel on Polygon. Our use case is to bridge funds from Polygon to Base. So in order to do that, we need to go through several steps. So the first one was deposit. The second one is opening channel on Polygon. And the third one is resizing our channel to move our funds from custody ledger to our network. And we will need to do the reverse operation when we do it with Base in order to withdraw funds there. So let's open channel on Polygon. Under the hood, it requests our clear node. Clear node prepares an initial state that is signed by our node. And when we get it, we sign the state as well, provide our participant signature and submit it to the blockchain. Next, let's use our resize command to move some funds from our custody ledger to our unified balance on Clearnode. Let's run it again. Okay, we will see. Here we will we see the three layers of our balances that we have in our system. So the first one was already mentioned is custody ledger. The second one is channel. For the sake of simplicity of this tutorial, we will just keep this step here, and we will move directly to the unified balance on Clearnode. So we see here that the first step is to specify the resize amount. Resize amount means how much funds you want to move between channel and custody ledger. We want to deposit from custody, to move from custody ledger to channel, then we need to specify positive 0.1 amount. The next one is allocate amount. That is the amount that is moving between channel and the unified on Clearnode. As our protocol says, it is how much we allocate from unified balance on Clearnode to channel. Then we need to do the opposite operation to top up the balance on unified balance. So here we will use minus 0.1. So think of it like this 0.1 moved firstly here and then here. Let's run the resize command. Under the hood, it do the same things as while we were opening channel. So like requesting our Clearnode. Clearnode prepared the state update for our channel, signed it, responded with it. We added our signature and submitted to the blockchain again. So let's run resize command on Polygon again, just to see whether our balances changed. Unfortunately, we just don't have the command to get balances right now. We will add it later, but we can check our balances through this command and just quit. Here we will see that our unified balance on ClearNode has been altered. Okay, now we are in the middle stage, and I would also like to show how we can receive and transfer funds. Here on the authentication step, we saw that we have the user tag that we can use to receive some funds. I will use my separate personal account, authenticate, and transfer USDC by tag. Okay, now it says it is 0. Let's resize here channel as well. We don't have here. Let's deposit. Okay, what about channels? We have channels. We have channel on Polygon and Base. Okay, let's deposit on Polygon. Okay, all right. Let's deposit 0.1. That was unplanned. I wanted this 0.1 to already be there, but that is not a problem. We will resize again. We will move this 0.1 here the same way that we moved them in our newly created account. Okay, and now let's transfer funds by tag. This tag 0.1. Okay, now let's run the resize command empty again, just to see whether our balance has changed. Okay, we see that right now our balance is topped up with the 0.1 that we received from my personal account. Let's exit the resize command, and now we go to the next stage to moving our funds from our account, from our unified balance on ClearNode to our wallet balance on Base. First of all, we would need here to open a channel as well. Okay, we have it. And here we go to the resize again. Okay, let's fetch it. And do the opposite operation to move the 0.2 to the channel and then to the custody ledger. So the movement between unified balance and channel was specified in the allocate amount, so that will be the second step. Let's imagine that we already have the 0.2 located here. Then we need to move the 0.2 from channel to custody ledger. That is indicated by minus 0.2, minus sign. Then we need to allocate an amount on channel. Those operations are atomic, so we don't really do this minus 0.2 before we do allocate, we just specify it later. Okay, let's write it here, 0.2. Okay, we have our transaction. Let's run our size command again, just to make sure that our balance moved to custody ledger. Yes, it does. Okay, and let's finally withdraw these funds to the Base USDC to our wallet. We have 0.2 and we withdraw them. Okay, that was the final operation. We don't close the channel because we want to keep it open for future transfers. We usually close the channel only if broker is unavailable, our node is unavailable. or we migrate to the new contract version. So now I just propose that we don't use it. So that is Cerebro in action. We've just performed complex cross-chain operation with simple intuitive commands. Cerebro abstracts away the complexity of state channels, custody management, and cross-chain coordination, giving developers and users a powerful yet user-friendly tool. Here are your QR codes. You can use it to examine our code base, and we are open to your questions.
Thank you. So before we actually take questions, let's make a quick announcement about the hackathons and other relevant tasks that has to be done. So thank you, Nikita and Anton, for this amazing session and for guiding us through the how developer can integrate Yellow protocol into their projects and ideas, and walking us through the implementation and management of custody and Cerebros CLI. So before we jump in the Q&A, I would like to request Beston team to drop the important links of hackathon. The people who have not submitted their idea, please go register and submit your idea to the provided link in the chat and be the part of winning the prizes from $22,000 of prize pool. And also join our Telegram community. You will be able to find the more similar developers, and you can find your founders and the teammates by putting your ideas and requests. We have more than 10,000 people in the group who can help you to build your projects. And also we will be sharing the uh, links and the scanners to claim your certificate for this workshop. Cool. So now we can take questions from chat. So I see that there are many questions asked in the chat. So you guys can pick one by one and answer them. If anybody want to ask their questions, raise a hand. We'll give you the stage to ask your question.
Guys, don't be shy. Ask your questions in loud. You have a great opportunity to network with the mentors face to face and ask and clarify questions regarding your project as well.
Please drop your questions. We are happy to help you and grow your business.
All right, while we are waiting for people to ask questions with their voice, we can start answering some chat questions. One of them is from Ravi. How do state updates or transactions within a state channel gets finalized or synchronized across different chains, since a smart contract on a single chain only updates detail on that specific chain? That's a great question. And actually, this is the challenge we are tackling in the next minor version of the Neutral-Light protocol. However, now this is the responsibility of the ClearNode. But obviously, it cannot stay this way, because if the node or the network goes offline because some attack or whatever, then the funds will become unavailable. We definitely want to avoid that, and therefore we are developing a protocol improvement, which for now we think will be a state shared across chains, which will contain information about user funds. So users will probably sign states which contain cross-chain information, but that's to be confirmed later. Another question from several people is asked about what are the best practices for optimizing storage variables in smart contracts that interact frequently with Neutral-Light off-chain sessions? I would say that highly depends on the blockchain you are building on. Currently, we're building on EVM compatible ones, so we are writing our contracts in Solidity. And I would recommend reading just Solidity documentation, some optimization articles, and to definitely use gas optimization runs parameter of the compiler. Also, you can always try to write an assembly code, but that highly decreases the readability. So suit yourself in here. Okay, I can see some other questions. Is there a size limit for off-chain data payloads in channel messages? No, we do not pose any at the moment. So I think the one that the limit would be of your connection quality. We'll set the limit on this. Currently, we do not pose any. And another question, what are the advantages of using the Yellow SDK over directly writing your own contract logic for state channels? Yellow SDK is another layer on top of the state channels. And when using Yellow SDK, you don't need to write any contracts. You don't need to directly interact with the blockchain. Yellow SDK will do that for you. And another reason why you don't need to write your own state channel implementation is that it is hard. As Yellow, we have already tried several state channel implementations, and they all have their advantages and disadvantages. So you need to know your use case great to understand which one to pick. As you can see, these are all questions. Guys, if you have any, you can ask now, or you can ask later in the chat. So I think that's it.
Yeah, I will share with you in chat, guys, have a Yellow SDK community group where we answer also pretty much of questions. So maybe you will find the answers there, or just type in Vistone chat as well. Thank you so much to our speakers, organizers, for making these happening today.
I think we do have some of the questions or ideas in the previous chat, so we can answer them. Like some people have shared their ideas. As a team, you can give them a feedback is how they can integrate the Yellow, what the best part Yellow can be integrated in their ideas. Like the one that like I'm building an AI based, like you already answered, Kate. The second one is I have already built and developed the MVP. It solves short-term capital restraint faced by the startup and SME by letting them create invoice and letting investors fund them while making a sweet yield at the asset-backed debt. So this is the question asked by the Abhi, I think. So we can guide them if we have any particular answer for. I can tag you. Okay.
Yep. I'm sorry, like the voice was So should I tell me what should I do?
Do we have any suggestions or anything to suggest them or evaluate this idea that this developer is trying to develop?
Like to evaluate ideas of the guys? For sure, yeah.
Yes.
Yep. Like you're talking about all 50 ideas or about
Yes. The one
yeah.
just tagged. Okay. No problem, guys. So please register for the next hackathon that is going to happen on next Thursday. We have already dropped the link, and don't forget to join Bisthon, and don't forget to follow Yellow Network on all socials and communities. So I'm sharing the scanner for to claim your certificate. Please enter your valid name, and that can be displayed on your certificate. Please scan and fill the form so that we can roll out your certificate. This is open for only next couple of like 10 or 15 minutes. Thank you, Kate, and thank you, Yellow team. We'll meet on next Thursday on the next topic. Thank you.
Thank you, guys. Bye-bye.
Thank you, everyone, for your presence.
Thank you, guys.
Yes, please submit your data and register for the hackathon, and don't forget to register for the next workshops. And all the links are available in the chat. And first of all, join our Telegram group. If you have any question related to the implementation or any question of finding your founder or teammate, put down your queries in the Telegram group. We will help you out to build your product and business.
Vaibhav,
Cool.
when can we get the recording of the session?
You'll get since tomorrow is the Independence Day, so we will share this to for a production. If we get the production ready material by today, so we'll share by tomorrow. Otherwise, over the weekend. If not by the weekend, Monday definitely will share the recording of these videos or workshop. All the workshop videos will be shared in the Telegram group. So don't worry, just join the Telegram group. If you have any question, we can also share the unedited or the branded videos for your reference.
Okay, Vaibhav. Thank you.
Cool. Thank you guys. See you soon. Please register for the fourth workshops. We are rolling out the certificate in the 10 minutes. You will receive your certificate over the email to claim your certificate.